Okay, now that we've reviewed the transformations that we learned last year, we're ready to put those together in what are called composite transformations. So the I can statement for 11.3 is I can understand and perform composite transformations. So that's our goal by the end of this discussion, is that we can all be able to do those composite transformations. We'll talk about what those are in just a second. But first thing I want you to do is I want you to circle all the transformations that preserve size and shape. So in other words, the ones that are rigid, the ones that keep the image congruent to the pre-image. So remember, translations, we just slide those around, doesn't change size or shape, so that one definitely is rigid. That one's going to keep it congruent. A reflection, all it does is make a mirror image. So if it's a mirror image, it looks exactly like the original one, maybe just flipped over, oriented differently or something. And then a rotation, all that does is turn it. That preserves size and shape, so that's going to be congruent. Okay, a dilation does not. A dilation fundamentally changes the size of the sides. It may or may not change the angles depending on what the scale factors are in each direction, but that one isn't. Now remember, what is the geometry word and the symbol for figures that are the same size and the same shape? Well, if you were listening, I just mentioned what it is. The word is congruent, so congruent, and the symbol is an equal with a little squiggly over it. So remember, numbers can be equal, figures are congruent. Now, a composite transformation is where we perform more than one transformation to produce a final image. And a composite transformation, when we do these, they're really no more difficult than a regular transformation if we do them one at a time. But we do need to pay attention to the order in which we do these transformations. And we've got some instructions, so if we do them in the right order and we're careful with every single one of these, then they're going to be pretty easy. Now, it might be a good idea to have your notes for 11.1 and 11.2 out so that you can remember what those rules are, the mapping rules, if you get stuck. If not, and you have these memorized, then you're in good shape. So again, this is 11.1. The translations, those are pretty easy. We're either just adding or subtracting something. Reflections, a little tougher to keep straight. Remember, reflect across the line y equals x. We switch the x and y. Across the line y equals negative x. Then we switch them and we change their sign. And across the y-axis, remember, it's the x-coordinate that changes sign. They stay in the same place, but the x-coordinate changes sign. And then by the same reasoning, if we're reflecting across the x-axis, then it's the y-coordinate that changes sign. And then we've got rotations and dilations over here. Remember, if it's a clockwise rotation or counterclockwise rotation of 90 degrees, again, we're going to switch the x and y, and then clockwise we change the sign of the x, and counterclockwise we change the sign of the y. And 180 degrees rotation about the origin, the x and y stay in the same place, we just make them both the opposite sign, okay? And then dilations are pretty easy. It just depends on what number we use to make those x's and y's bigger or smaller. So I'm going to come back here and we're going to take a look at these problems here. So it says, for examples 1 through 3, use the graph to draw a dotted version of the new figure after each transformation. So every time we do a transformation, we want to draw a dotted version of that one. And then when you finish the composite transformation, so once we're done doing all of these, then we want to shade and label the final figure. Okay, so it says reflect over the line y equals 3. So here's what we're going to do. We're going to take this, and I'm going to change to a little smaller marker here. So we're going to draw the line y equals 3. Here's our line of reflection, okay? Now, it just so happens that that point is on the line, so it's not going to go anywhere when we fold it along there or reflect it along there. But this C point is 3 units below, so we're going to make this 3 units above. And this one is 3 units below, so we're going to make this 3 units above. So if I wanted to, I could label this C prime and B prime, and then this again would be A prime. And then I'm just going to do a dotted version of that right there. Now, depending on how many of these we have, this could get a little bit messy. I'm going to go ahead and leave that line of symmetry for right now, and we'll just kind of see how this works out and see what we get. All right, so then it says a 90-degree counterclockwise rotation about the origin. A 90-degree counterclockwise rotation about the origin. So that means we want to take these points right here, and we want to do a 90-degree counterclockwise rotation. So I'm going to write down what A prime is. I'm going to write down what B prime is, and I'm going to write down what C prime is. And I'm hoping we don't have to do this on every single one of them because this would be a total pain. Let's see. So A is negative 4, 3. Negative 4, 3. B prime is 0, 6. And C prime is, let's see, negative 4 comma 6. So negative 4 comma 6. Now remember, if we're going to rotate 90 degrees, we're going to switch the X and Y. So we're going to switch the two of these. So here's going to be our A double prime. So here's going to be our new A. So this is going to be a 3, and this is going to be a 4. 3 and 4. Now remember, if we go counterclockwise, remember it was the Y coordinate that changed. So I think I'm going to get this one right here. So this is what I think. When we do a 90-degree counterclockwise rotation, we switch the X and Y, but we have to multiply the Y by a negative. Now, I'm going off memory here. I haven't done a whole lot of practice with this. You've probably done more than I have at this point, but let's go back and look at rotations. So rotations, 90 degrees counterclockwise about the origin. Yep, we switch the X and Y, and the Y, the one that's in this spot right here, we multiply by a negative. So it looks like we got the right thing. So let's keep doing this. Let's multiply by a negative here and just move this one over here. Multiply by a negative here, move this one over here. Okay, so this one's going to be negative 6 comma, that would be a 0. And this one's going to be a 6 comma negative 4. Okay, now let me just double check and make sure that I got that right. That comes over here as a negative 4. That comes over here as a 0. That's still a negative 4. Change sign, and change sign. This one was, remember, this was negative 4, 6. So this should be negative when we move that over. It looked like there was a negative there. Okay, glad I checked that. Okay, so let's go ahead and graph this. And for the sake of keeping this straight, I'm going to highlight these guys here that I'm going to graph, and I'm going to change colors on this one. So let's see. We need to do negative 3, negative 4, back 3 and down 4. Let's see. And then negative 6, 0, negative 6, 0. And let's see, negative 6, negative 4. So we're right here. So again, this was A double prime, this was B double prime, and this is C double prime. And let's see how this looks. Okay, well that actually looks pretty good, because what we did here is, notice that B prime was right up here, okay, straight up there, and now it's straight over here, and that definitely is a 90-degree rotation counterclockwise. Okay, so I think we're in good shape with that one. All right, now we want to reflect this over the y-axis. Okay, so luckily this is going to be a little bit easier. Again, I'm going to change colors again. If we reflect over the y-axis, here's the y-axis, and the only thing that's going to change is the x-coordinate's going to change. So instead of being negative 6, 0, we're going to come over here to 6, 0. So I'm going to put B triple prime. Now, I'm not going to do this on every single one of them. I just want to make sure that you understand how we do this kind of technically. This one is over here, 3 units, so we're going to go 3 units over here. So this is going to be A triple prime. Okay, so we've done 3 transformations at this point. And then this one is over here at negative 6, negative 4. So this is going to be 6, negative 4. So this is going to be C triple prime right here. So again, we're going to do a dotted version. Oh, I forgot to do a dotted version in this green stuff. So let me change back to there. Okay, keep this straight. All right. So these take some time to do. And then here's the last thing that we want to do. It says, what are the final coordinates? So let's go ahead and write those down here. So we end up right here. Oh, and this one is the last one. Okay, good. So we're done with this one. So I'm just going to draw these lines right here. Okay, and then I'll go ahead and shade this in. So this is the final figure. So we flipped it up here across the line y equals 3, then we rotated it, and then we reflected across the y-axis. So we end up right here. So I'm going to write down these points then. So A triple prime is, this was 3, negative 4, 3, negative 4. And then B triple prime, that was 6, comma 0. Okay. And then C triple prime is 6, comma negative 4. Okay, so that answers this guy right here. Those are all the points right there. Now, are the figures congruent? Well, you know, it's certainly oriented differently, but if you think about it, have we done any dilations? If we haven't done any dilations, this is the same as the original shape. So that angle B triple prime would be the same as angle B. The length from A triple prime to B triple prime would be the same as that length right here. I think you can kind of tell that those two would be congruent. We could kind of slide them around, rotate them, and it would lay right on top of each other. Okay, so let's slide down here and let's take a look at the next one. All right, on the next one, and I'm hoping this one goes easier. It says reflector of the line x equals -4. Okay, so x equals -4 would be this line right here. Okay, so we're going to take that, and these points would not move. Okay, and we're going to take this one, and we're going to reflect it over here. So if it was 4 units away from the line of symmetry, it's going to be 4 units away from the line of symmetry, but on the other side. So I'll do a dotted line right there. Okay, and then we want to translate this. Oh, we want to reflect this across the y-axis. Okay, so on the y-axis would be right here. Okay, so if this is 8 units over this way from the y-axis, we're going to reflect it way over here. Okay, and if this is 4 units over here, we're going to reflect it 4 units over here. And if this is 4 units over here, we're going to reflect it 4 units over here. Remember, the y-coordinate doesn't change at all when we reflect it across the y-axis. So here's what we've got. Okay, this is the shape we're dealing with right now. Okay, so we've done the reflection across the vertical line x equals 4, reflection across the y-axis. Now we want to translate this left 4 and up 3 units. Okay, so left 4, 1, 2, 3, 4, and then up 3, 1, 2, 3. So I'm going to put a dot right there. So I'm going to call this A, 1, 2, 3. So I'm going to call this A triple prime. Okay, and then let's see, back 4 and up 3. So we're going to call this one, that is a C, sorry. That's C triple prime. And then this one was that pointy B, so we're going to go back 4 and up 3, so we end up right here. So this is B triple prime. Now, we don't have any others to do, so I'm going to go ahead and connect these. Probably should have done those points in, or labels in blue. Okay, so this is what it looks like. Okay, that's the final figure. Now, are the figures congruent? Well, gosh, you can kind of tell. The answer to that one is yes. And how would you explain to somebody why they are congruent? So we could make these kind of informal arguments that we were talking about before, like, look, the distance from here to here and the distance from here to here, and this angle looks the same as that angle right there. But if we were to look at the slopes and the lengths, we can physically count off some of these. So we could go through and we could say, look, 1, 2, 3, 4, 1, 2, 3, 4. So those are definitely congruent. And since this is horizontal and that's horizontal, they both have the same slope. And we could also look at this right here and say, look, this is down 3 and over 4. So that one has a slope of -3/4. Well, if you look at this one, down 3 and over 4, this one also has a slope of -3/4. So there are several different ways where you could look at this and say, you know, this should be a really convincing argument that these two triangles are indeed the same. Okay, let's slide down here and take a look at the last one on this page right here. Okay, it says reflected over the x-axis. So we're going to take this and reflect it over the x-axis. So remember, if you reflect it over the x-axis, it's the y-coordinate that changes. So this is going to instead be -4, 3. It's going to be -4, -3. And these are on the x-axis, so they don't go anywhere. So this was a really easy transformation to make. And you can see that they're reflections across the x-axis. Then it says reflected across the y-axis. Okay, well, that's easy. We're going to take each x-coordinate and change it to be the opposite of what it used to be. Now, this one right here, it's at the origin, so that one just stays right there. And then this one is going to come over here and be, instead of -4, 0, it's going to be 4, 0. And this one, instead of being -4, -3, is going to be 4, -3. Okay, so what we've got here is I'm going to call this B double prime. I'm going to call this C double prime, and I'm going to call this A double prime. And then since we're done, I am going to go ahead and draw the lines in blue, and I'm going to fill in that final shape. So we're going to make it look like this. Okay? Now, if you look at these are definitely congruent. We could make the same arguments that we did on the previous example. But what I'd like you to look at on this one is, could we have done this with one single transformation? Gosh, I mean, take a look at this. We could have taken this and made it exactly like this transformation. We could have swung this over here, that one stays in the same place. Well, if you think about it, this is a 180-degree rotation about the origin. So this was heading off in this direction, and I'm going to change colors here. It was heading off in this direction, there's the old one. Heading off in this direction, there's the new one. That is a 180-degree rotation. So we're going to write 180-degree rotation about, remember that's the typical phrasing, about the origin, about the very center of the graph here. Okay, let's take a look at the other side. Okay, now that we're on example 4, we don't see much matching or multiple choice or anything like that in a math class, so this looks kind of interesting. So let's pay attention to the instructions here. It says 6 images are shown below. Match each image with the shape and orientation of the transformation. Figures may be used more than once. That might be important. You may need to estimate rotation angles and dilation factors. So you may need to take a guess. Oh, that looks like roughly 90 degrees clockwise or counterclockwise, or maybe that was a stretch or shrink of, factor of 1/2 or something like that. Okay, so let's take a look here. So I says a reflection over the line y equals x. All right, so I'm going to come over here and I'm going to draw the line y equals x. So I'm going to draw it just like this. Okay, I don't need much more than that. Now here's what we need to do in order to make a reflection. Anything that's below the line over here, we need to flip it over there. So these points get to stay on there, but I'm going to flip this one up here. Okay, I'm going to take this one and I'm going to count 1, 2 spaces this direction. Then I'm going to go 1, 2 more past that. Then I'm going to do this one. I'm going to count 1, 2 and a half to get there. So there's another half one and then 1, 2. So I'd be right there. And then this one right here is a half a unit on the upper side of the line. So we're going to make it a half a unit on the lower side of the line. And then these two, gosh, they kind of switched places. And this one is right on the line. So here's what it looks like. We're going to go here. Whoops. Let me catch this again. We're going to go here, 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 and here. Okay, so that's the reflection of the blue figure over the line y equals x. So all we need to do is match it up with one of these, and I say it matches up with B, or D. Now, we're not going to cross that one off completely because it says the figures can be used more than once, and we may come back and use that again. So in order to clean this up, I'm going to go ahead and do this. We're going to go ahead and get rid of that, and then we'll move on to the next one. Now, whether you want to do this one or that one doesn't make any difference. I'm going to do this one. It says... let's see, translate right 2 and down 1. So let's take this first point right here on the L. Let's go right 2 and down 1. We're right here. Okay, right 2 and down 1. We're right here. Okay, this one, right 2 and down 1. We'd be right here. Right 2 and down 1. We'd be right here. Right 2 and down 1. We'd be right here. Okay, we'll take a look at this. This is what it would have to look something like this, okay? So remember, a translation, all we're doing is we're taking something that's kind of like a placemat and sliding it around. So that one's going to be A. So we're going to mark that one as A because that's the same as the original pre-image figure there. Okay, let's do item V. So this is the 5th one. And it says a rotation of 180 degrees about the origin. Okay, now, if you need to use the rules to do this, go right ahead. I'm going to take this and I'm going to draw a line straight to that one. So instead of going over 2 and up 3, I'm going to go back 2 and down 3 so that we'd end up right here. Now remember, drawing this line is a good way to tell where how much the rotation was, but it's also a good way to tell what the rule was. Remember, what we do with the x's and y's is they stay in the same place, they just become the opposite sign. So on that point, it ends up right here. On this point right here, if this is 4, 3, this is going to end up being negative 4, 3. So negative 4, negative 3. Sorry, negative 4, negative 3. This one is negative 4, 4, 4. This is going to be negative 4, negative 4. So we're going to be right here. This one is, let's see, what have we got here? We are 3, 4, so it's going to be negative 3, 4. So negative 3, negative 4. And then let's do one up here. So this would be 3, 7. So that would be negative 3, negative 7. Negative 3 and negative 7. So we're down here. And this one would be 2, 7. So we just switch the signs. Negative 2, negative 7. Negative 2, negative 7. And I think that's enough information that we can kind of tell what this is going to look like. It's going to look like that, okay? Now, what we've done here is we've rotated this all the way around there, okay? So let's see, which one would it be there? Have we got one like that? We do. It's going to be B. So we'll put a B right there, and then I'm going to go ahead and erase that stuff. And let's see, what's the next one? So we want to flip this over, or that would be a reflection over the line y equals 3. And then we want to slide it to the left 4. So y equals 3. Let's see, y equals 3 would be this one. Okay, horizontal line. And then we want to slide it to the left. So if we flip this upside down, the shape would basically be like this. And then if we take that and we slide it, so if we were to take that and slide it left 4 units, it would end up over here. Let's see, 1, 2, 3, 4. Yeah, so it would end up looking like this, okay? So it ends up being this shape right here either way, so that one right here would be F. So we're going to mark that one down as F. So I'm going to go ahead and get rid of that right there, and let's take a look at the next one. So the next one here is IV, so that's a Roman numeral 4. So shift left H units and down K units. Okay, well they didn't even give us any values for this, but if we were to shift it left, if we went left, take every point and move it left, and then down a certain number of units, well, it's going to take the shape. Again, this is just like sliding it around. This is like this one right here. So this is going to be A again, okay? So that leaves us, we've used a bunch of them, but we've got to figure out this last one. And this one's pretty easy. It's stretched by a factor of 2, so it's twice as tall, twice as big as it used to be. And then it's turned 45 degrees clockwise. Well, of all of them on here, the only one that's been made twice as big is this one right here. All the lengths are twice as big as they used to be. And then it was rotated 45 degrees clockwise. Well, 45 degrees clockwise would be like this right here, okay? A 45-degree rotation. And that kind of matches the orientation of that one right there. So we're going to say that this last one, Roman numeral 6, VI, that is going to be E. And remember, it said we didn't have to use all of them. So we used D, we used A, we used B, we used F, we used A twice, and then we used E. This is the one that we didn't use. Okay, so let's slide down here and take a look. It says which of the figures above would not be congruent to the original figure, and explain your answer. Well, notice that here's our original figure, and these 5 right here, they are still the same size and shape. It's just the orientation or the way it's been flipped or something like that that's been changed. E is the only one that would not be the same. E is not congruent. And why not? Simple reason. It was a dilation. It had a dilation in that composite transformation, so that means it's not going to be congruent. It was made a little bigger, a little smaller. In this case, a little bigger. Okay, let's come down here and take a look at example 5, and then we'll be done with this. It says, use the graph to draw a dotted version of the new figure after each transformation. When you figure the composite transformation, or you can finish the composite transformation, shade and label the final figure. So same instructions as we had up above. Hoping this one's a little easier. Reflect across the over the x-axis. So the x-axis is right here. So we're going to flip this down here. So it's going to look like this. Okay, so there's just the reflection. Dilate by a factor of 1/2. So what we're going to do on this is we're going to take every one of the coordinates and we're going to make them half of what they used to be. So 0, 0, if you multiply each one of those by a half, it's still 0, 0. Now, negative 4, 0. So if we start with negative 4, 0, if I were to dilate that by a factor of 1/2, if I do half times 4 and if I do half times 0, I end up with 2, 0. Okay, sorry, negative 2, 0. So that would be right here. And then this one would be the point. This is negative 4, negative 3. I need to do half of this, so I'm just going to divide everything by 2. So this is going to be negative 2 and negative 3/2. Or if you wanted to, you could do negative 2, we could write that as negative 1.5. Okay, so negative 2, negative 1.5. So we're about right there. Okay, so I'm going to change colors so we can kind of tell what this dotted version looks like. So that's what it looks like right there. And then it says rotate that 180 degrees about the origin. Okay, well, if we rotate that 180 degrees about the origin stays right where it was. So it's going to be right here. If I take this and I rotate it 180 degrees, whether I go this way or this way, it's still going to be on the x-axis. So that's going to be right here. And then this point, remember, it was, let me make sure that looks good right here. It was the point negative 2, negative 1.5. So remember what happens with these. They switch signs. They don't switch places, they just switch signs. So this is going to be 2 and this is going to be 1.5. So we're going to graph 2 and 1.5. So we're going to be right here. So we're going to draw that. And this is the final figure. Okay, so it looks like this. I'll even shade that in so it looks good. There's the final figure. We did 1, 2, 3 transformations. So if you wanted to, we could label this as, this would be A triple prime. This would be B triple prime, or sorry, this would be C triple prime there. Okay, so this would be C triple prime, and this would be B triple prime right there. And the last question is, Are they congruent? Well, the answer to that is no, they're not. You can definitely see they're not. And the reason is dilation. We had a dilation in there. It made it smaller, so that means they're not the same. All right, go ahead and fill out the ICANN self-assessment right here. How good you feel about these composite transformations, and then good luck on the assignment.